we are. First day of finals. Welcome everyone. From the audience. Anyway, teams have 15 minutes to give the presentation on this for the semester, capping up also if you did, lessons learned, all those fun things. I've got your little warnings or timers. Then we have about 5 minutes for questions. So
we have clients in the house.
And we have some clients in the house, so be nice. Anyway, should be good. With that, I think we're ready to start. Chartopia.
Hello everyone, we are Team Terratopia and welcome to our final presentation. No. First, let me introduce our fantastic team. We have Yuxi, Yue, Yan, Meng, and Jess, and our instructor is Heather and Shirley. Our client is Lori and Diane from main campus, and we also have B as our consultant for research studies. Our client wants us to make a VR experience that allows the player to experience challenges brought about by climate change. And specifically, players will play as dolphins, overcoming challenges in the ocean. Our target audience is adults and high schoolers. And since our client wants to produce a series of similar experience in the future, this project needs to be made for future development as well. So some people might ask, why do we need to make a VR experience in dolphins' perspective to illustrate climate change issues? Well, we found the answers from some research studies. So we can increase players' empathy for dolphins and make them more aware of the climate change issues. Well, our ultimate transformational goal is to let the player get a greater awareness of how animals are impacted by climate change, feel empathy, and get a better understanding of the interconnectedness between animals and the human, eventually feel motivated to take more actions. Now I hand the mic to Yuxi.
So a big question that we had was, how do we connect dolphins to climate change? And dolphins are affected by a lot of different things, such as noise pollution and so on, but none of these have a direct connection to climate change. And our solution to this was mangroves. They are a carbon sink, and they are the foundation of a huge ecosystem that dolphins rely on for catching their prey. Along with that, our client wanted us to convey a hopeful story, and we did this by telling the story of mangrove restoration through 3 phases. Phase 1 is our healthy environment, mangrove ecosystem, then we have our destroyed world, and finally our hopeful restored environment. And for this experience, we play tested over 100 play testers with ages ranging from 11 to 30 plus. And overall, we had pretty positive feedback because people quite enjoyed the experience of being a dolphin. And with that, we did get a lot of different input for how we could improve, which brings us to our challenges and how we iterated over that to improve on our overall game. So our first challenge was that we wanted players to really experience that feeling of swimming as a dolphin, but with the acceleration and compulsive camera movement that comes with it, a lot of players were experiencing motion sickness. And this was especially prevalent in our original time warp idea, where players would feel sick when we kind of limited their movement and pushed them forward through a tunnel. So our solution to that was to have a transition animation at the very end of our healthy environment, where players would come across a scene of excavators digging through and digging out the mangroves while they still had full control of their movement. Along with that, we also added a dolphin nose as a visual anchor. Our next challenge was that players did not understand the general gameplay and the story, and they often forgot how to and that they needed to catch fish and echolocate. Along with that, they also didn't feel very connected to the dolphins. So we had 2 solutions for this. Our first solution was that we decided to take advantage of the very social behavior of dolphins and implement a chat box where dolphins would let the players know the story as well as guide them throughout the game. And our second solution was to implement a tutorial. However, our first iteration of this was a auto-played timed slideshow, which we realized that players often glossed over and forgot about. So we iterated on this to be more action-oriented and essentially had a dolphin instruct the players to do all of the game mechanics before the game actually started. And now, Meng will talk about echolocation.
Thank you, Yuxi. Echolocation, as one of our most interesting and attractive game mechanisms, also met many challenges while developing. We found out that players often forgot to use the echolocation, especially in phase 2. They complained that they need stronger feedbacks, including visual and sound feedbacks. We also met some tech limitations for fish highlight, which is the visual feedbacks of the echolocation. To solve this problem, what we introduced is a ripple effect in front of the dolphin itself to assist the player in engaging the range of echolocation. In addition, the dolphin pods in the environment also have that kind of a ripple effect to remind the player to use the echolocation in the environment. Addition to that, we also have highlighted the fish during the echolocation so that the player can see the fish in the darkness. We're using post-processing as the strategy of making the highlight a feature that is not supported by Quest 2, which we are used to develop in the first half of the semester. But the good news is the very new version of the Quest 3, supports the post-processing that we finally can implement this into our game. We have done multiple iterations of the echolocation, and this is the very first version of our echolocation. As you trigger the echolocation, you can hear a sound, and when there's a fish in front of you, a corresponding sound will bounce back to you. But we end up with just having one sound rather than two, because it takes long and is not how dolphin works in the real world. And this is the final version of our echolocation. As you can hear, the sound of echolocation are different depending on if there is a fish in front of you. We collaborate closely with our client, who are expert in field of dolphin echolocation sound, and to ensure that the echolocation that we use is clear and more easier for the player to understand. After briefly talking about the echolocation, let's jump into our different phases. To recall that we have 3 different phases: the health environment, the destroyed environment, and the restoration environment. In this phase, the player as a dolphin will explore the world, which is a health and hopeful environment. There are a bunch of fish surroundings that they can hunt, and also they can explore the environment until they, as a dolphin, found out there's something that they did not recognize. We also met some challenges based on our feedback of phase 1. Players are getting lost in the map and unsure about the goal of this level. So to get rid of these problems, we resized our phase smaller to make the player prevent them from getting lost from this environment. And also, instead of creating a round root environment like this, we are designed it to be pretty straightforward so that the player will not get lost. And this is the overall environment of our phase 1. As you can see, it's a really beautiful, healthy undersea world with some caustics on the ground, God rays, sea surface and AI-generated skybox, and also some color tone adjustments to make it even more calm and chill. We also have many the animations to fish and dolphins to make it even more real. It looks just alive in this environment. You can see the dolphins and fish swimming around, idling, hunting, making conversations, or even dying. So combine this together, we are creating a very healthy, beautiful underwater world. However, after excavators digging out all the mangroves, things change. So let's pass to Yue to talk more about the destroyed world.
Thank you, Mo. So next is the phase 2. Phase 2 is the environment that has been destroyed by the climate change. Our goal is to make the player feel immersed in this level and to know the harsh reality of the climate change. And to reach that goal, we restrict the player's visibility and also decrease the light intensity of the level to create a dark and unpredictable environment. And here are some mechanism visual feedback in this level. If the player eats a fish, there will be a fish in player's mouth, and when the player hit the right height, the screen will turn to red. And when the player do the echolocation, there will be a ripple effect in front of the player. And our fish can be hit by the red tide. After the fish dead, if the player eat the dead fish, their screen will be green and indicate that the player is getting poisoned. And when we do the pretest, we realize that the player is very easy to get lost in this map. And here's the following reasons. First, our map was so big that the player would not sure where they at. And the second, the fish can distract the player from finding the road. And last but not least, the limited visibility and the dark environment even make it worse for the player to find which direction they are facing to. So for solve this problem, we have two solutions. First is the right tide. Right tide is an ocean problem caused by the climate change. And we put a huge right tide behind the player. When the player moving forward, the huge right tide will follow the player. And when the player going backwards, the huge right tide will remain stationary and block the player going back. And besides of the huge right tide, we also have some small right tides. We place them in the face and place them in a specific area to avoid the player go to some place that's easy to get lost. And also we have some random generated right tides. With the time pass by, the right tides will getting more and more, and it will enhance the intensity of the level. And here's another solution. It is the fish generator. Initially, we just randomly put the fish in the level to use the fish as a environmental storytelling to indicate the player that there are less fish in this level. But we realized that the player is more focusing on catching fish instead of finding a way out. So we removed some fish and used the fish as a guidance for help the player to find the destination. But as I mentioned above, the fish can be killed by the right tide. So when the player finding the fish, if the fish already killed by the right tide, they can't find the fish. So eventually we came up with this solution. This is the dynamic fish generator. So when the player doing the echolocation, it will automatically generate a fish next to the player, and it will always direct to the right destination. So the problem is solved perfectly. And next, Jess will talk about the phase 3 environment.
So finally, we wanted to end our game on a hopeful note. So we had the player enter into a mangrove restoration area. But when we first had our first iteration, people were kind of confused on what this area was. So we implemented a mangrove restoration sign for divers to see, and also some mangrove seedlings, as well as having you welcomed by your dolphin pod, welcoming you to this healthy new environment. We also connected this directly to conservation organizations working on mangrove restoration, actually in the real world, which we displayed at the end of our game, showing real world pictures of this happening. And then the festival, we set up, we had a pre and post game survey to track our transformations. And we also did a study that was based off Danny Pimentel's study of like when he would give people some money after their game and they could place it into different organizations where they felt inspired to give. So that was we were tracking that as well. But from our survey data, when people were asked if climate change is a problem that needs to be addressed, this definitely increased. And we also had the elimination of people saying not at all, which was great. And then also is to achieve greater awareness of climate change impact on animals, we achieved this because people said that that they did learn something new about climate change issues. So we were very excited about that data. And then also the statement about asking if they are interested in learning more about what they could do, or also wanting to learn more about these issues. Overwhelmingly, everyone said yes. And we actually had QR codes that people could scan to learn more, and many people scanned those. So we felt that it was really promising results. So next is Jan going to wrap up everything for our game.
Okay, thank you, Jess. So we packaged up all the relevant files for future development, and we also learned a lot in this progress. We learned the performance optimizations for VR projects, and we learned how to design and iterate our projects better. So that's all. Thank you for listening, and we are ready for questions. Thank you. Is there any questions?
I noticed in phase one there was some text in the scene, and text in VR is often a challenge to get people to read it, especially when the text is moving or the player is moving or the camera. Can you talk a little bit about iterating on how you presented text inside your VR scenes?
Well, thank you. So we all know that text is quite annoying in VR games. So at the beginning, we don't plan to do so in the VR. But you see, as for like storytelling perspective, we have to have it. So in phase one, we have all the text chat box stand there, but they will always look at the player, so that player will always read them, and it's in a steady frame. But we are also having another chat box which will keep in front of the camera of headset. So like in tutorial and in the final like slideshow, so we have two chat box for different situations, so that player will not be annoyed by the chat box and they can see it clearly. Thank you.
So, based on what you've learned, what would you do differently?
So yeah, I would say the biggest problem we have encountered is about equipment. So like Meng has mentioned, we have to use Quest 2 in Oculus Quest 2 at the first half of the semester, and we received the Quest 3 on the second half of the semester. So a lot of programming and art style are based on the performance of Quest 2. But if we are doing that again, we will do more logically designing and playtest at the beginning, so that we don't have to rewrite some programming from Quest 2 version to a Quest 3 version. That's quite annoying. And yeah, I'm pretty sure that's the biggest lesson we have learned.
So let me ask a second part to that. Besides the tech, I'm talking about content. What would you do differently? Presenting the content.
Okay. Sure, I would say like at the beginning, we are very confident that using our storytelling techniques, we can let the player like get aware of everything we want them to know without any literally text in the story. So, but we do the playtest and we realize that's not the solution. So I believe for a semester-long and a 4 minutes long VR performance, we will more use the text material to help the player to get a better understanding of the story itself, rather than just using the camera movement and the art style, everything to help them to know that. Thank you. I hope that answers the question. Yeah. Any other questions?
Do you see, as a team, excuse me, do you see a future in this kind of work, this sector, which is different than others? Do you see a future?
In transformational games? Definitely. Yeah, definitely. I mean, I feel like from just talking to some of the people who played this game, a lot of people didn't even know what mangroves were. and then also, I think it's very encouraging from some of the feedback that we got that people felt inspired afterwards. So I definitely think there's a future in this.
And for you as in this field in the future?
Yes, definitely.
What would you say the most important transformational goal of the experience is, like that top of hierarchy goal?
Well, we've been asked these questions on playtest day because we know that climate change is a big issue. So I would say the ultimate transformational goal for our project is simply to get people's awareness so they can feel empathy and feel motivated to do more after playing our game and share this game with their friends to let them know, oh, there's a bunch of animals suffered from climate change, and that's all we want. Thank you.
All right. Thank you, team.
Thank you.
Hello everyone, we are Team Picolog and our instructor is Jonathan and Mike. So here's our team and our client is PicoCTF. So we need to make a game for middle school and high school students and to engage their interest in cybersecurity, specifically cryptography. And this is a short demo of the game. So it's a 2.5D puzzle-solving game, and unlike other PicoCTF game, our game is made with 3D assets with fixed camera angle. And there are 3 levels and 21 puzzles, and there are different cards in the game, in the levels so the player can collect along the way, and they need to use those to change the objects in the scene in order to solve the puzzles. And the puzzles are inspired by actual ciphers such as Caesar cipher and Spartan cipher, which will be explained later. And after they solve the game, a key or new cards will appear. And players will collect those keys or cards, and a pop-up window will appear with tutorials about the information about the cipher that inspired the puzzle, or the tutorials about how to use a card. So for our final, we have 3 levels and 21 puzzles and our tutorial informations. And Simon will talk about the research.
Thank you, Tina. As Tina just mentioned, our topic is about cryptography. So what is cryptography? After research, we found out cryptography is a complicated subject. So it's about math and computer science and information technology, etc. It's very complicated. And we kind of wonder what kind of game we will make. Are we making a visual script encoding or decoding game? Or we make a game play with letters? Or we make a first-person cryptography maze game? After discuss with our client, because our first initial goal is to teach players cryptography, but after the discussion, we find out what we need to do is engage the players' interest in cryptography instead of teaching them. So, because this prototype is to ask players to solve mathematical problems, but it's sometimes too difficult for teenagers to understand. So what we need to do is extract the idea of actual problem and apply them to our game. For example, a Caesar cipher is to shift letters by a constant pattern. And in general, actually, in cryptography, every encoding or decoding method is to modify data 1 to data 2. So we use shapes to represent data blocks. After some patterns or player apply some cards, the shape 1 becomes shape 2. And here, based on it, here comes our core game mechanics. The players can use mouse only to explore our world and to interact with objects by applying cards, which is our main game mechanics. And we use shapes instead of letters to represent the data changing. And we also implemented the dialogue system, so the player, after they read the dialogue, they can learn the concept and the history of some cryptography. And in the end, we made 5 cards. The player can use them to solve puzzles and pass levels. And we have 3 levels. The level 1 is about classic cryptography. Level 2 is a modern one, and the level 3 is about cyber attack.
Okay, so let me introduce our art part. So just a quick reminder what we did before halves. So we have created our characters. And also our environment. So this island you can see here is fully procedural generated. So it's easy to get different variations and easy to extend the level. And also we design our main mechanism, which is the card. And we create different collectibles, such as the key pieces. And after half, our highest priority is to decide to use different color for different levels. So for the first level, because it's more beginner friendly, it's more easy puzzles. So we choose this green color to make it look like more nature and to give players, to let them feel more relaxed. And for the second level, because it's about more advanced puzzles, and we use this high-tech blue color. And for the third level, it's about more hard puzzles. And also we want to make the players feel more intense. So we choose this red color. And as a result, teenagers really like this art style. And after halves, we also create different art assets. We added more cards to give players more interact possibilities. And also, we create more puzzle-related assets, such as the shape puzzles you can see here. We use it a lot in the first level. And here, we have different puzzles in level 2 and level 3. So just a quick example, you can see the white gate here. This is represent the private key in modern cryptography. So its usage is to decrypt data. So you can see we transform the blue cube to an orange cube. This is our way to visualize this decryption process. And also, to give players a full game experience, we also need to create a user interface. So you can see here, this is our start menu and pause menu. And we also consider some players may not have a mouse with middle mouse button to let them to control the camera zoom in and zoom out. So we create this in-game slider to help them. And also, we have different mouse cursors. So when your mouse hover on different items, it will change to different icons, which let the gameplay more intuitive.
So to further integrate our art assets with our core game mechanics, we designed 21 puzzles in our games, and all of them are inspired by ciphers. So in our level 1, our puzzles are inspired by, it seems to have some problems. It's inspired by classic ciphers such as Caesar cipher and Spartan cipher. And the player's target in this level is to match the position and also the shapes of the object to the checker. And for our level 2 and 3, the puzzles are inspired by RSA, which is a modern cipher. And as mentioned by Snow, the data is trying to transmit through the gates and to change the shapes to match the target. And in here, the shapes are represented as the cipher text or the data, and the gates are represented as the decryption and encryption process. And we also went through a lot of the puzzle iterations in our game. At first, we made our puzzle in the paper, that before the halves, and also we made a first-person version of our game. Since at the beginning, we want to make a game that's with the exploration elements and also the puzzle solving. However, we found out that players actually get lost in our levels. That's not what we want, since we want players to focus more on our puzzles and ciphers instead of the level. So we made our half version, which is a 2.5D game. However, actually, in that version, there's no other clear instructions for players to know what's going on. So we made our iteration V1. In this one, we put some of the art assets provided by Snow to the environment and actually make a checker to connect the target with the objects to give players a clear sense, which target is checking for which object. But still, some players think this kind of play is not strategic, since they only have to play one card for 2 actions, and they think they actually didn't learn anything about the puzzle. That's why we add some depths to our iteration V2. In this one, players have to implement multiple cards into the puzzle to try to solve it. And we also make some of the objects to be rotatable and to give players more choice during the puzzle solving. But there are still some frustrating points. As you can see, the key is not placed in the correct place. It's far away from the path to the next island, so the player actually don't want to take the key sometimes. And also, like the checkers material is the same as the objects material. So players actually can't recognize it clearly. And also, it's not color-coded. So the rotatable object is the same as the fixed object. That's why we made our final version like this. At first, we color code some of the objects here, and the blue object can be rotatable. This message has been transmitted clearly to the players. And also, we use another material that's more clear to the players. And we change the position of the keys to a correct place. And there are more small iterations in our development process, but we're not going to mention it here.
Next, I'm going to talk about our UI and UX improvements. They can be categorized into 4 parts: a user menu, on-screen UI, pop-up windows, and visual hints. So we made a user manual. This is embedded into our game menu system. The player can, whenever they want during the gameplay, go back to the main menu and review these informations, such as Cypher introductions and all of our game tutorials. So back at halves, when players are interacting with a tutorial item or pick up the key, we only show them a dialogue like this. And now we change the dialogue to a pop-up window. So we're providing them with both text and visuals to help them better understand the information. Also, when the pop-up ends, as you can see on the right, it goes into the game menu button to emphasize that player can later go into the game menu to review this information. We also integrated a lot of on-screen UIs, as mentioned earlier by Snow. This is the example of the zoom slider the player can use to zoom in and out of the camera. And we also put a exclamation mark onto our hint robots, so they're inviting the player to click on them. Here's the actual example of how our cursor changes responding to the different types of objects it has been hovered on. We also added a lot of visual hints to our game. So on the left, you can see our highlight effects on solid objects. On the right, the highlight effects on the transparent objects. We are using this highlight effect to indicate the player whether or not they can apply a card onto an interactable object. So a lot of our puzzles actually rely on the fact that player cannot interact with objects that are too far away from them. This is our version at halves. We do not have any clear indicator of the use range of the player, so it can be confusing when the player selects a card and some objects are highlighted and some are not because they're too far away. So this brings us to our first iteration. We use the Unity decal projector to project an image onto the ground. This gives player the sense of card range, but it falls off when the player goes to the edge of an island because nothing shows up when there's no underlying meshes. So in our final iteration, we use a ring to indicate the card range. This gives user a very clear sense of where they can apply the cards and where they cannot. According to our builds, we have currently 2 builds, one on itch.io. This one is used for most of our playtests as well as our festival because players do not need to have an account to play. The other one is currently on PicoCTF's test server. So on PicoCTF's website, which is our final deliverable, we also develop a new feature, which is the account-based save and load functionality. So this allows players to save their progress, and the next time they come back to it, they can load that progress.
So we have done several playtests throughout the semester, and we have a total of 19 playtesters, and 31 of them are below the age of 18. So we asked that their willingness to learn about cryptography before and after they play our game, and we can see that their willingness have increased. And this data is completely based on the people aged below 18, which is our target audience age group. So here are some faculty and playtesters' feedback. So they think that it's a fun, informative game, and there need to be a clear connection between the differences and the differences between the puzzles and actual ciphers, which we already implement in the game. So the lessons we learned that inspirational puzzle design, difficulty control, UI, UX interaction details, as well as iteration based on playtest. And here's our client feedback.
For this project, we presented Team PicoLock with a tough task: to create an educational game about cryptography, a subject that is often off-putting. to new learners because it can contain high-level math concepts. This game plays a crucial role in our cybersecurity education platform because it has to both introduce good abstractions of these complex ideas, while at the same time being fun and engaging to encourage further learning, going deeper into the material. To that end, I'm really impressed with Team Picolog's progress in the last few weeks. They have produced our most visually advanced game yet, with a remarkable level of polish and continuously improving iterations. I think my favorite part is towards the end of the game, where I and some of my colleagues were almost wondering if one of the puzzles was misdesigned or broken, only to be rewarded with great satisfaction later when we realized we had to go a bit outside of the box, how we thought things should work. It's that exact same energy that totally embodies the core of Pico CTF, and we're excited for our users to get to experience this game in our upcoming learning module. For this project,
So to summarize, Picolog is a game aiming to raise middle school and high school students' interest in cryptography. And we have playtested the game and got positive feedback from clients, playtesters, and faculty, and it will be deployed at Pico CTF website. And that's all for our final presentation. Thank you for listening.
So it seems like you made a lot of changes over the course of the semester. What did you find working on this that surprised you the most?
So what we found is that at first, actually, we want to teach the students about cryptography. But during play, actually, some students are not interested in learning things, but they are more interested in playing. So that's why we shift our design decision to make this game more fun. Instead of the copy-paste, the cryptography ideas, we want to make it to fun in abstract ways. So that actually is a good outcome. And they feel more interested in learning cryptography at the end, which is strange but fun.
Yeah, I might have missed this. Is the game available for anyone to play? What's the current state of the deliverable?
It's currently available on h.io, but it's also available on the test server on Pico CTF's website. And on the test website, you can save and load states. Thank you.
Hello, we are Team Cheat Code. We are the generative AI game team, and this is our team.
My name is Chloe, the artist on the team.
I'm Felicia, I'm the UX UI in the team.
I'm the VFX artist in the team.
I'm James, the programmer on the team.
And I'm MK, the producer of the team. And our advisors were Mo and Ricardo. So our project was focusing mainly on something only generative AI can offer in gameplay. So our game is two-player game happening in weird grocery store. And users can populate groceries on fly, any items they would like to see in the game. And it's gonna happen in real-time generation, which means the riddles and also scavenger hunting of the gameplay is also made at the real time. So here, we'll watch the demo together. So at the start, it was very open-ended project. Our purpose was to explore possibilities of generative AI in game in general. So we had to ask a lot of questions to ourselves, including what can AI enable gamers and developers, and also what is AI good at and what is AI not good at, and also how is the industry using generative AI in current stage. Out of many things to answer, we came to narrow down stuff like deciding to focus more on play experience rather than productivity and design choices. And also we locked down on generating 2D assets and also text as the output of generation. And now Chloe will explain about our design choices.
Thanks, MK. So at first, as a team, we started to think about what is AI good at. First, generative AI is good at repetition, patterns, and mass population. Therefore, we set the environment as the grocery store. Secondly, in terms of response rate, when it's kept at a small batches of images, just like our game, the response rate was pretty quick, such as like 10 to 15 seconds. Also, it's quite good at mishmashing fun, different prompts into one wacky image. So we tried to use this as a meaningful usage of gameplay. On the other hand, what is AI not good at? At that moment, the 3D generation generative AI wasn't so good at making game-ready assets. Also, in terms of quality, it was quite incoherent. Therefore, we needed to come up with a strong theming of this wacky, weird, dreamy environment to serve that weakness of generative AI. Also, when it comes to real-time generation, the level design wasn't so playable. Therefore, we went with generating riddles and image assets. This is our early stage gameplay chart. In the beginning, we had player 1 as the guard. They would type in a text prompt. Then DAL-E would give the image asset to the environment. Then player 2, the thief, had to look for that asset in the environment. However, most of the feedback that we got was that player 1 felt too overpowered in the game. So we modified it a lot. We tried to balance it out by giving them the equal opportunity. So player 1 will type in applefish, a text prompt. Then DAL-E would create an applefish asset somewhere in the environment. And player 2 would type in bug milk per se, and then we'll do the same in the environment. And they'll go through riddle solving to look for each other's item. So this is where the real challenge came in, balancing out the fun and the meaningfulness in our gameplay. So our limitations weren't really set by generative AI's limitations, but rather the good old game design problems. So this is our first iteration. We had 1 input, 2 riddles, and 1 output. From this, we realized that we needed to encourage the real fun of mishmashing different prompts and creating weird, wacky images, and we often found the clues very redundant. So this is the next quick iteration we made. This case, we had 3 inputs, 2 riddles, and 1 holistic output. In this case, the clues were quite unclear and found unhelpful. So we tried to parse the 3 riddles each by each, such as ice cream, blueberry, and peanut butter. In this case, it gave players a lot of confusion on the number of items that they needed to find, which also resulted in players desiring to pick up more items. Then we tried to iterate it again. In this case, 3 input, 3 riddle, and 3 output. The results, as you can see, was more reliable. However, it wasn't as fun. It was just very normal and bland. Then we tried to bring back the mishmash back without confusion. So this is our final iteration with 3 inputs, 3 riddles, and 3 outputs. As you can see, it has this very fun, creative images that also serves right with the theming of our environment. Another small challenge that we faced was the generation time. As we mentioned, 10 seconds to 15 seconds wasn't too long when we were just talking like this. However, in-game, that's a long waiting time for the player. So we tried to come in with this fun cutscenes and onboarding tutorials to have the player ready to play our game while they wait and to keep the interest curve up. We also needed a strong character design to tie all the theming together. So we have this one NPC named Wiseman. It's very long and has this bulbous, unbalanced head, which gives this humorous energy, but also this uncanny vibes. We also tried to make some winning and losing cutscene to tie everything together, as well as the 3D assets to create this whole atmosphere. Last but not least, we also did work with generative AI in terms of pipeline as well. These are all created from the concept arts created by Midjourney and then hand-painted by people. We also tried to make zones corresponding to the categories of the items. This is not only a visual signifier for the players to indicate where they are standing right now, but also creating this fun and wacky atmosphere in the scene. This is also one of the interesting part that we did, lighting design coming in together with game design. So light design in our game actually visually signifies where the players have to head next. They turn turn off each by each until the player finds the last item that they need to find. It keeps up the interest curve of the players, and we also have UI to reinforce the direction. This was another way to aid the player's gameplay without the need to downgrade the quality or the difficulty level of the riddles given by ChatGPT.
So we also have camera iterations during our playtest. We have changed the default third-person camera to a more smoother and friendly camera angle by changing the camera view, adding zoom-in feature, and limited the angle. And we also tested the outline and the pixel on the post-process to fit in our visual style. For the visual effects, we have separated them into different sections such as nature, bakeries, sparkling on the coupon machine, ice and freezing, and all these visual effects follow three principles. There is gameplay, color, and shape. Taking the sparkling on the coupon machine as an example, the focus is to catch the player's attention to find the object, so it has a higher saturations and contrast range to create a focus area, and also has a combination of the hand-painted and a combination of hard and soft lines on the shape to avoid visual noise.
So Tech Solution, our game is a PC game and it's developed with Unreal Engine 5.2. It can interact with ChatGPT 3.5 and DALL-E 2.0 using the Unreal plugin called HTTP GPT, which provide blueprint nodes. And here are more details about how AI is involved in our game. So for each player's input item, it will first use ChatGPT to categorize it and put it into the right section. For example, it will categorize a light bulb pizza and maybe put it into a bakery section based on the response. Then it will use ChatGPT to generate a riddle, which the answer is the item. Finally, it will use DALL-E to generate the image of the item. And we also cannot train the AI and test with different prompts to let the image kind of fit with our dreamy style. And how to generate the item on the shelf. So our item basically is a 2D image with a dynamic material so that it can be changed in real time. It has two parameters, the base color and its corresponding opacity mask. So for the general item, it will just randomly choose a texture from our pre-filled library. But for the player-generated item, it will just use the DALL-E image as its base color. However, the problem is DALL-E cannot generate its corresponding opacity mask, so the background cannot be transparent. That's another limitation we found. So we just set its background color to be black to let it hide under the shadow and tricking the eye.
Thank you, James. After finalizing our game design, we're wondering how could we deliver our gameplay to player without compromising their in-game experience. As a result, we're using 3 different methods to guide user before they entering the main stage. The first one, we utilize graphic design skills to simplify and organize the language we use in the mix and matching gameplay to an informative interface where player learned how their inputs will affect the result and how the product will be merged together. Then we create cutscenes to convey the main narrative. It's really effective through the playtest that is not only keep our players entertained, but also deliver the main message. We also use motion graphic to highlight the change throughout the interface, which keep the players more engaged throughout the tutorial. One of our goals for this semester is to deliver a playable demo by the end. As a result, we playtest every single week with our instructors, consultants, and faculties to gather valuable feedback of the playability of our prototype. Below are the four main portions our approaches. One is related to interactable objects. When a player working close to an interactable object being seen, they have a clear UI reminder on where and how they could interact with it. This is really helpful with the naive guest throughout the playtest. Then we include a inventory panel where players can track all their riddles because it's possible for them to remember everything they see in scene. And after the soft, we implement our status tracker, where it gives an overview of their progress, and it indicates how many items left for them to secure the victory. Last but not least, we implement sound effect. This gives player a direct feedback if they pick up the correct item, since we have populate the store. And now I'll hand the microphone to MK.
Thank you, Felicia. So on our last playtest, we found 87% of our playtesters found they enjoyed the customized gameplay experience, and 94% found they had enough or high freedom in creating items in the game, and also 82% found they were pretty satisfied with the generated images. And surprisingly, 100% of playtesters found they wanted to play our game again. So in overall, we can confidently say that we could prove that AI usage on real-time generation and customization enabled meaningful interaction between players and in-game world, which led to unique and immersive gameplay experience. However, we had some more rooms for improvement. If we had more time and some more data we could collect and weave with the level design, we could work more on improving riddle clarity and image representation and riddle level. To review our overall project, our challenges were finding our own direction throughout the Blue Sky project, and also balancing between exploration and also keeping the playability. But what went well was the process of connecting the dots all together and also working with the technology to serve the design. So we would like to say thank you for all of the faculties and playtesters and our advisors. And also now we are open to questions. Thank you.
So you've spent a few months now trying to figure out ways to use AI for new game development. What thoughts do you have about, as we look forward into the next few years of game development, what do you think, do you have any predictions about where do you think AI will be the most useful for game development?
I feel like for that question, we can definitely split it in between like programmer side and then from art side. I think from the art side, or as a team as a whole, I think we all agreed that this whole semester, there were so many myth bustings going on about surrounding this rumor surrounding AI, generative AI. However, we all agreed that for now, if we were to choose between friend or a foe, it's more of a friend. And also we perceive it more as just an additional tool that we need to learn again. So when it comes to game design, definitely moving forward from narrative to just pipeline, but also using it as more interactive engagement between player and the game experience, just another element that ties the player and the game world together, more like an active involvement and customized gameplay. That's how we view it. And
from programming perspective, I think the all the resource, like the image generated, definitely can be like pre-filled or pre-made, but like using AI can generate a great amount different types of image. And also another key thing is learning, because AI can learn during people play, so they can generate better riddle or generate better image based on the user's input, and the game can also like iterate through people play the game.
So I think the keywords would be tool, friend, customized, catered gameplay.
So we've talked a bit about the fact that you can't really release the game. You can't just like put it on Steam or whatever because of the AI tools that you're using. I'd like to hear more about what you have decided to do and where the status is of that as far as getting it out into the world so other people can play it.
We haven't really looked up like the policies about the Steam release, but maybe there might be some way. But currently we're more considering of like submitting our work to somewhere in between indie game festival and some research AI related like experimental game venues. So we're currently preparing for PAX for now, and then some human computer interaction like student game competition and so on.
So I was interested in the final iteration of your gameplay. When you get to the having it generate one object and then the combination of two objects and the combination of three objects, how did players respond to that? Was it easier to find the object that was just one element and then it kind of got progressively harder? Was it based on kind of location, like they found the one closest to them first? Like how did that affect the final gameplay?
Yeah, thank you for the question. Actually, that's like another element that we actually wanted to talk about. It's another aspect that aids the player's playability without lowering the difficulty level of the riddles that are generated. So as you can see, all three images there are kind of related to each other. Somewhat includes banana or like banana pie in some way. So based on the image assets that they find, that actually becomes the clue to another objective that they need to find. So yeah, in terms of playability, this iteration definitely helped us as well.
Thank you very much.
Hi everyone, we're Team Avalon Blues, and this is our team. And we're gonna show a demo video of our team project.
John Smith Hurt was born in Teac, Mississippi in 1893. His parents, Eason Hurt, were attending a local talent show. Okie took John to Memphis and New York City. Mississippi became the blues legend of his generation.
But 100 years later, Pocket Road. This land brings in
This is an interactive installation designed and built for the Mississippi Junker Museum to capture the life, challenges, and enduring musical legacy of the Mississippi Junker. We did a lot of research and worked very closely with our clients to make sure we obtain and convey the true stories with historical footage, old photographs, and 3D stylized animations. Using a nearly 70-year-old radio as an interactive interface and the TV as a window to the past, we teleport guests' attention to the 1920s and 1960s so they can take a look at Daddy John's life and learn about a piece of the history of African Americans living in the Mississippi region. The fundamental constraint behind this project was durability. Rigidness drove every decision behind the tech. and all of our hardware and software are carefully implemented and tested to make sure we deliver a long-lasting educational experience.
Okay, so Mississippi John Hurt is a country blues musician known to be the key figure of the 1960s folk music revival. And so our project goal is to capture the life story of Mississippi John Hurt and also tell the hardship faced by the African American community in the Mississippi River Delta. And our client is the Mississippi John Hurt Foundation, led by the founder, Mary Frances Hurt, who is also the granddaughter of John Hurt, and also Valerie Turner, who is a co-president, and she herself is a blues musician. So this is our agenda today. Chapter 1, we're going to go over the overview, and Chapter 2, we're going to talk about challenges and solutions. Chapter 3, we're going to talk about plans onward. So Shen is going to introduce our overview for today.
As an overview of our installation, we created a display screen, an old radio, and a knob that can tune into the timeline bar on the radio. Our target audience would be young adults, and our goal is to deliver an experience that is emotional, true to the story, and long-lasting. For the radio design part, we have a tuning knob that is the only interaction approach between our audience to the digital content. Then there is the timeline. On the timeline, there is the chapter indicator that indicates main incidents of John Hurt's life stories. Between the chapters, there are sounds, which is a main musical piece of John Hurt's creations. Then there are needles, which is our indicator, and our logo. The team logo is not interactable. Then Play will talk about the installation space and guest experience.
So we will put the installation in this church. And this is an imaginary rendering of the installation. And our guest experience will be divided into 4 steps. So first, the guest will walk into the church and turn the knob. And then the monitor corresponds to the input. And finally, there will be music and documentaries playing. And our documentaries have 5 chapters which tell the story of John Hurt in different areas. So first chapter will focus on John Hurt's early days and his guitar learning and Jim Crow laws. And second chapter tells about John Hurt's first commercial recording and his struggles during the Great Depression and the story of Emmett Till. Chapter 3 talks about Hurt's comeback and his musical success, how blues music rose with the civil rights movement, and John Hurt's at the end of Hurt's music career. Chapter 4 tells about Hurt's music legacy, Mary Frances Hurt's vision, and the Mississippi John Hurt Foundation. And the final chapter features an interview with Mary and her message to teenagers. And for the medium content, our videos will consist of 3 parts, which is historical footage, photos, and 3D animations created by us. And of course, we have 4 sounds for our guests that have been featured previously in all 4 chapters.
Thank you, Play. I'll briefly talk about the challenge we have while developing this project. The first challenge is how to narrate the story. As we briefly mentioned, we have a lot of information about John Hurt online is very incorrect because they're mostly portrayed by white media. And we spend a lot of time to go through the final text with both of our clients to make sure that we have the final edition, which has a very good tone as well as it's true to the story. And after that, we process those texts with Charles because he has a very powerful voice. He's a very experienced narrator, which saves a lot of time. And recording with him is very budget friendly because you don't have to fly him in. And there's always the flexibility to change because sometimes we have to reiterate the text. And here's an example of his narration.
A speech that continues to symbolize the movement. Interestingly, one of Dr. King's favorite songs was John Hurt's version of I Shall Not Be Moved.
So as you can see, we're already trying to weave some of the African American history into John Hurt's timeline. But how can we make it better?
And the way to do that is to do it via the static sound. We mix static sound with historical speech as well as media content, so that when the user is tuning the knob, you're kind of hopping over different time of the history. And here's an example of that.
Even made television films.
Killed in the 1963
From the fatigue of despair to the buoyancy of hope.
So this one is mixed with the 16th Street Church bombing incident, as well as Dr. King's speech, with both happening around the same time of the history. The second challenge will be our copyright materials, because this is a permanent installation that's going to live for years. We don't want to make sure that everything we handle to the client is going to be legally safe for years to come. And here's is basically how our contents are composed with. We have a lot of Creative Commons materials as well as copyright clear materials. Those are footage and photographs. We have 28% of them that's made in-house, including 3D animations, as well as the footage that we shot during the Mississippi trip. But we still had 24% of them that are not copyright clear because we cannot reach out to the author or the owner of the clips. But under the fair use permit, we should be able to use them mostly because we're building a nonprofit and educational experience. But why is that still a problem? We're still kind of talking about it? Because after consulting with faculty member as well as CMU legal department in CMU, we were advised that there's still some potential risk for our client because it's a permanent installation. So our solution to that is to offer the client with an A and B version of our contents as a very cautious sort of design. So the A version will contain all of our collected materials, which will serve a more complete educational experience, while the B version contains only the copyright clear materials, which will serve as a backup plan if plan A doesn't work out. So here's a difference between A version and B version. As you can see, we have more materials on the A side, but we can still convey the story on the B side. So this will be toggled by a switch, which will physically build into the radio for the client to use.
Then is another challenge, which is the art and animation part. Because when we were creating the content, we found we don't have enough historical footage to tell all the stories we want to tell. So we have to create 3D animations by ourselves to fill in the gaps. We created a customized stylized shaders to unify all the art assets in Blender to make it consistent to the historical footage. We made a lot of iterations based on the feedbacks. Before halves, we thought about creating this kind of film noir style black and white looking, but this kind of black and white looking feels too close to the historical content. Later, the illustration on old newspapers inspired us so we decided to change our shaders and add this kind of hatching shadows and old newspapers background. So we created an art style that is consistent to historical footages, but also different from the historical footage and unique. One thing that wasn't mentioned is John Hurt has a unique finger-picking style of playing guitar. So we take a deep observation of how he moved his fingers and recreated that in our 3D animations.
So a major challenge, of course, was how do we make sure that people are able to still actually engage with our exhibit? So here's a very high-level overview of our final design. We consulted extensively with Dave Perda in regard to actually constructing and designing this hardware. So the guest interacts with the radio dial, and then we receive that signal to our single board computer and process and display that output. We opted for a Raspberry Pi 4B because it's entirely passively cooled, so there's no active component. And over time, when we would test and run it for over 24 hours, we noticed no degradation in performance. We also replaced the original radio speaker with our own speaker that's sourced from a car part manufacturer because this resulted in a speaker that filled the space very evenly. We also, out of an abundance of precaution, installed a relay in our power and a backup battery. So if the relay gets flipped, if our client accidentally, or someone in the museum were to accidentally unplug our installation, this would initiate a safe shutdown on our single board computer while the computer remains powered with the backup battery. We opted for a potentiometer instead of a rotary encoder to pinpoint exactly where our dial is, both when the experience has started, if the dial is off from the beginning, as well as to ensure that it can remain operational over time. Even though potentiometers over many, many years potentially get fuzzy in how they output their signal, it won't actually negatively impact your ability to engage with the experience because we're just looking for input over a wide acceptable range for where you're tuned. We have a 55-inch industrial-grade TV donated to us by Electrosonic that is designed for 24-hour continuous use, even in warm weather. And we have a very tall, very sturdy TV stand. We also have a waterproof box that we are housing all of our electronics in that is mounted on the back of the display. And the only electronics that actually live inside the radio are the potentiometer and the analog to digital converter. Everything else is mounted on the back, along with our A and B switch and power and reset buttons. For software, we had to actually do 4 full rewrites of our video output, and the final data structure we went with was a simple node network where each radio station contains its video output and its audio for the transition to the next radio station. And when the guest dials and tunes to a different station, then the pointer is updated, and at any given point, only 3 videos and 3 audio transitions actually need to be loaded in memory. And now Ray will be talking about our upcoming plans.
So plans onward. So we are going to be delivering this actual installation to Mississippi this Saturday, 16th. And on the very next day, it's going to be the important day, the installation day. And we're also going to be handing off the user manual to our client. And before the delivery, we're almost done with the B version. We're finalizing the wiring, and also we're focusing on the user manual, finishing it up this week. And this is our special thanks, and we're open to questions.
So the AB solution to this copyright problem seems like an okay answer given a 14-week semester. Would you solve it the same way if you had more time, or would it change your creative vision? Have you thought about that?
Well, something we realize by dealing with copyright is some copyright materials have a certain expiration date. Let's say this one material requires like they only give us for 2 years, and the other only have like, let's say 3 months. So B version actually works out pretty good if the installation going to last like even further than the years we sort of promised.
Having gone to all this work to put this documentary together, are there other ways people can experience it? Is there a way to share it with people without having them to be in Avalon, Mississippi and messing with the tuner?
Yeah, so what we will end up producing along with the user manual is that we're going to edit all our videos together as a long 12 minutes of clips. So that's something that the client can use to, let's say if our system accidentally gets shut down for life. But that's one of the safety measures that we promise we will deliver. So this could be something that anyone can watch. Obviously, the B version is safe for online, but A version we probably have to watch like closely in like a closed space.
Two-part question. First part, when did you fully realize the limitations of the copyrights and their impact on your work? And the second question is, if you had known at the beginning of the project that there were these limitations, could you explain alternate ways to approach the installation and the material you were going to include?
I think for the first part, we fully realized this after half. We have some understanding of this is a pretty serious problem, but we thought that fair use is going to cover for us. But just to be extra cautious, we talked with Mike, and then we think of this idea of having 2 versions. As for the second question, I think as a team, we're pretty satisfied with A/B toggle because it's a pretty clever way to, like, again, extend even the expiration date of copyright protected materials. So if we were to probably like make some changes, we'll start thinking about the A/B version way ahead of the schedule.
So on the, when I was looking at it at festival, there was some kind of performance problem where the frame rate would drop sometimes. Have you made any progress on this?
Yeah, so our performance has been an interesting journey with this project, but the version that we currently have that is operational when at 1080p actually performs pretty well. We were able to continue to iterate and really just refine our actual processing logic and get some performance back there. So over sustained use, it is very consistent. There's still some screen tearing, but there's no more there's no sort of dip in audio. Initially, the version you may have seen had when performance issues occurred, sometimes you would get choppiness in audio, which was very distracting from a viewer perspective. That has been eliminated entirely. And we're hoping to continue to still chip away and hopefully eliminate the screen tearing, but we don't consider it experience breaking.
Have you considered just having lower resolution video as possibly being acceptable for this in order to get it smoother?
We have experimented with a bunch of different types of like compression. So our actual display is capable of 4K output, and initially that was the goal we were shooting for, is displaying 4K video on our 4K display, and we already scaled that back to 1080p. We may scale that back a little bit further, but if we go too far, I think it hurts the readability of the subtitles, so ideally that won't be necessary.
Thanks.